In this video, we're going to talk about a couple more limit laws that we didn't go over in the first part here. Um, these limit laws have to do with raising functions to powers. And so the theorem says, suppose that the limit as x goes to a of f of x exists and n is a positive integer, then the limit as x goes to a of a function here, f of x, raised to the nth power, okay, is going to be equal to the limit as x goes to a of f of x raised to the nth power there. So as long as this limit exists, right, then powers are no problems with limits either, right? If I have the limit of a function raised to a power, then I can just take the limit of the function and get that number and then raise it to whatever power I'm raising it to. So that works great for positive integer, so whole number powers here. And the second law here is about the nth root of a function, and we can see that the limit as x goes to a of the nth root of f of x, right, provided that this limit exists, right, what we can do is just take the limit as x goes to a of f of x, the function underneath the nth root part, and then get that number, and then take the nth root of that to get the answer. For this one, right, if n is even, we've got to assume that the limit as x goes to a of f of x is positive. So the reason for that condition, right, is that you can't take the even root of a negative number and always get a real number out, right? That would wind up with a complex number, and in more advanced classes you can deal with that, but in this class we are only looking at functions that have real number inputs, right, and real number outputs is what we want to do. So we restrict that situation in the case that n is an even root, like a square root or a fourth root or something like that. So in the next couple of videos, I'll show you how to apply these rules to take limits.